Hello YouTube, and welcome back to another video. Welcome to this series on coding interview questions. This is Ming Tech Media, and today we're going to be discussing the two-sum problem. It's also referred to as the find two numbers that add up to a target value n. You'll see it referred to in a while as those two names. And here's two solutions to this problem. One is a more brute force and naive approach. I won't go through that, but I'll explain it very briefly. It uses nested for loops, and for each iteration on the outer for loop, the inner for loop runs n times. So what you want to do is you want to select an element, or you want to start at an element on the outer loop, and for the inner loop, you'll go to the next element, and you'll add each subsequent element to the element in question on the outer loop to see if it adds to the target value n. But we won't go through that solution because it is very time intensive. In fact, it is an O of n squared time complexity. What I will go through is a solution which involves a famous algorithm, quicksort, and the solution in total is O of n squared. And what we want to do with the array, because you're given an array and you're given some target value n, and you have to find two numbers in that array that add up to that target value n, what we need to do is, sort the array first, and then use pointers to figure out where in the array we can find two numbers that add up to n. And I'm going to explain this more as I go through this video and go through this problem with you. But first, we need to code out the quicksort algorithm, which uses partition to partition an element in the array in its sorted position. So everything to the left of it is going to be less, everything to the right of it is going to be greater. If you're not familiar with quicksort, I do have a video coming up, if I have not already released it, on quicksort, explaining its time complexities, its analysis, and the overall inner mechanisms of the algorithm. But in a nutshell, what we're going to do, let's start coding. It's enough talking. What we're going to do is we're going to have a method signature of public static int, because we're returning an integer, and we're going to name this partition, right? And what partition is going to do is going to take in an integer array, we're going to name it ARR array, an int low value, which is basically the beginning of the array, and an int high, which is basically n minus 1, right? Which is the length minus 1, right? That's the method signature, right? And then what we're going to do is we're going to select a pivot, and the pivot value is basically the value that we're trying to sort of work around. We're trying to see whether all the other values in the array are either less than or greater than it, and then we'll do some swaps and comparisons, and then put it in its final place when it's all said and done. So the one thing to note about sorting algorithms like quicksort, merge sort, and heap sort, there is a lot of swapping and comparisons involved. In fact, these are how some of these sorting algorithms work, by doing comparisons and swaps while iterating through some sort of array, or that kind of thing. It could be a linked list too, but mostly it's going to be arrays. So here we go. So basically that's the first thing we do. We select the pivot value, and that's going to be array high. Then what we're going to do is we're going to because we have to have two sort of variables that go through the array and do these swaps and comparisons. So the first variable we're going to have is int I, and we're going to set that equals to low minus 1, right? If I can spell low minus 1, and that's just the index of smaller elements, right? The second thing we're going to do is we're going to iterate through this array with another variable j, and we're going to set that equals to low, and we're going to do j is less than high, because you remember high is our last element in the array, and j plus plus. And then what we're going to do, we're going to have an if check to see if array j is less than or equals to pivot, right? And if it is, what we want to do is we want to iterate that I. So we can't start at the first value. We can't have I equals to 0. Usually when usually the number passed to low as a low parameter is 0, and this is n minus 1, or length minus 1, so AR length minus 1. We can't start at 0 because you can't start the first element and compare it to itself. That's not, you gotta start an element before it, so and it will make sense to actually iterate it to the next if a condition isn't met, right? So basically what we're going to do after that, we're going to swap, perform swap of ARR I and ARR J. So, a lot of people, they use like an external sort of helper swap method. I'm just going to do the swap in here. You can do it either way you like. That's just my preferred, that's just my preferred method of doing things. And this is just normal swap procedure where we just have a temp variable and we throw something into that temp variable and set, that variable which is thrown in to what we're swapping it with, which is array J. And then what we're going to do is we're going to set array J equals a temp, which is the original value of array I. Temp. There we go. Next thing we want to do, why is there an error message? Int. Oh, int. I said int. It's supposed to be array. All right. Don't worry about this error message just because I haven't really returned anything yet. So then after that's performed, right? Let's say we go through all this and all that swapping is done and comparing is done. What we want to do is we want to swap array I plus 1 and array high to put the pivot in its actual sorted position. And once it breaks out of this for loop here, basically we want to do that work just to set the pivot in its proper position, right? So what we're going to do is going to perform pretty much the same thing, a swap, but with just different elements. So it's going to be array I plus 1 and array I plus 1, curly braces, nope, we need square brackets, I plus 1. I plus 1 equals, and we're going to set that equals to array high. Semicolon, and array high is going to be equals temp, right? And then after that's all said and done, we want to return, it's got to spell return right, I plus 1, which is the actual sorted position of the pivot. I spelled return right, gee whiz. Alright, so you see that other error message went away, and this is basically your partition function. And what we want to do under that is we want to actually code out our actual quicksort function, which is going to just do recursive work on the left and right sides of that pivot. So we're going to have a method signature of public static void sort because it's not really returning anything. And one thing I also note, and I don't want to make this video about quicksort, but it's good to know these things as an engineer and as a problem solver trying to solve these problems. Quicksort is an in-place sorting algorithm, right? You see how this void is here? I don't have to everything is being done in place essentially, right? So I don't have to have an auxiliary array like in merge sort to where I have to create extra space just to sort the array. So if space is a problem, people usually go with quicksort, right? It's not a problem. You can go with either one, but you know, the space is you want to consider all your factors when selecting an algorithm to use, and that's definitely a big factor, space. So we're going to basically have almost the same type of method signature that we had for partition. And then what we're going to do is we're going to have, this is called a base case if you're not familiar with recursion, which you should be. Like, I honestly feel like, you know, you're not going to understand a lot of the problems I do, or in general, even the problems that you see out in the wild, like on LeetCode or HackerRank or something. You're not going to understand them if you don't understand basic fundamental computer science concepts like recursion. So if you don't, like, go and understand recursion first, and you know, try and come back later. But yeah, that's the base case. If low is less than high, basically is the condition that is going to terminate this recursive function. We do an int pivot index, and we're going to set that equals to partition. And what we're going to do is we're going to pass the array RR, and we're going to pass low, and we're going to pass high. Right, and then for the actual recursive part where we're actually sorting, we're going to run sort, and we're going to run it on the array, then low, then pi -1. So basically that's everything up until pi, you know, so from 0 to pi -1, or the element before it, because remember we did the swap. Now the pi, or the pivot, is in its rightful place, where everything to the left is less and everything to the right is greater, and we're going to keep on doing that until we have a sorted array, and it does that under the hood. So what we're going to do is we're going to sort, and then we're going to pass the array again, but this time we're going to start at the pi +1, which is the element right after pivot index, and do that up until high. And yeah, that's basically it for the actual sorting. Now what we want to do is we want to write a find sum method, and remember what I said about the pointers and how we're going to move them based on whether some condition is met. This is it. What we're going to do is we're going to select 2 pointers, one at the very beginning, which is usually whatever variable name you have, 0, and then the end is, you know, the length of the array -1. Alright, so the next thing we're going to do is we're going to define a function called find sum, and it's going to take in an int array and a target value n, and it's going to use this sorting function here as a helper function to help it sort the array first before we use 2 pointers to kind of traverse through the array and see if we can find like a couple of numbers that add up to our target value n. So let's go ahead and define that function. It's going to be public static, let me space that, public static for int, and it's returning an integer array with exactly 2 elements, right? We're going to call this find sum, and what we're going to do is we're going to have that int array. You know, you guys know I love ARR, sorry, and int n. So first thing we're going to do is use helper function to sort array. So down here we're going to come and we're going to say sort, take the array in, take 0, the first element, and remember what I said, array.length -1, because we want to get to the end. I don't know why my computer's slow like that. Yeah. The next thing we want to do is define pointers. Oops. We're going to have 2 pointers. We're going to have an int pointer1 and that's going to just be equal to 0. And ints pointer 2, and that's going to be equal to the array dot length minus 1. Next, what we're going to do, we're going to define our result array. And like I said, it's going to have exactly 2 elements. So we're going to say int results equals to new int, and we're going to have 2 elements in there. And then int sum 0, because we're going to need some sum variable that we constantly change and check, you know. So we need to set that equal to 0 first. You'll understand while as I code. So we're going to also need to do a while loop. So we're going to have some condition to check, and while it's not true, so while pointer 1 is not equal to pointer 2, we're going to do some work. All right. So basically what we want to do is we're going to take that sum variable I just created, and we're going to do array pointer 1 plus array pointer 2, right? So we're just going to keep on adding this, and we're going to have an if check. Trying to figure out why there's an error message. What is this error message? Pointer 2 can't be resolved. Oh, I forgot the I. All right. So like I said, we're going to have some if check, and it's going to go like that. If sum is less than n, what we want to do is we're going to increment from the right. So pointer 1 plus plus, right? And then else if the condition would be sum is greater than n. And if it is greater than n, what we want to do is we want to decrement from the left. And then in our else block, what we want to do, our else block is just going to be if, like, you know, we come to, you know, find the actual results. So if it's not greater, if it's not less, that means it's actually equal. So that means we have to return a result, the first element, or not even return, we got to set the first element equals to array pointer 1. And I'm just going to copy this since it's going to be almost identical on the second line. So 2, and then change that to 1. All right. So this is basically the bulk of this function. And then if all else fails, you know, what we want to do is just want to return this array right here. And then there it is. That's the whole method there. Well, there's about 2 methods in this class, you know. We have 3 actually. We have the partition, right? And that actually sets the element in an array in place in its actual sorted position, and then we're going to do that and run that recursively on both left and right sides using this sort function. Then we have a find sum function, and what it does is it takes this sort method and takes the array and whatever integer value. It takes the array, it takes the first index of the array and the last index of the array, and it kind of just sorts the array, right? And that happens within this find sum method. And in the find sum method, we're passed an integer array and we're passed a number, a target number. We want to set our pointers to 0 and the last element in the array, and you can always get that by doing array length minus 1. And then what we want to do is we want to define our result array, because if we do end up finding these numbers, we need a 2-element array, right? And we also need to define sum. I should probably do something like that. Yeah. we want a 2-element array, and then we want to define our sum, and then we're going to run a while loop, and if this condition is not true, so basically if while pointer 1 is not equal to pointer 2, what we want to do is we constantly check the sum each iteration, and if it's less than n, we want to increment the pointer from the right side, and if it's greater than n, we want to decrement the pointer from the left side, so it's going to, you know, slowly inch towards the middle. And in the else block, if these two conditions aren't true, then that means it's equal to they're equal to the target number. So we set the first element equals to pointer 1, and or array pointer 1, the position of pointer 1, and the second element array pointer 2, position of pointer 2, and if that all else fails, we return the array. So let's just see if this works. I'm gonna code up a main function, right? So where are we at? We're gonna start from here, add a few enters, public static void main string args, and you can put these pair of brackets right here anywhere. You can put it behind the args or behind the string, it doesn't matter. I just like it behind the args, it looks cleaner. And then we have int n, and I'm going to set this equals to 13. And then int, and we're going to have an array 1, and I'm going to just put some values in here. I don't know, 1, 7, 6, 5, 3, 2, 3, 22, 22, 17, and 11. And maybe one more, 9, just for the hell of it. All right, next what we want to do is, what is this error message? Figure out, I think I need an extra pair of braces. Is that gonna work? Nope. Oh, that's probably what it was. Int arrays equals to, okay, and then we have that. That should be, there we go. All right, yeah, after a while, you just become good at debugging and can just do it on the spot. Gotta get used to reading these little messages and warnings and stuff like that. But here we go. Next, what we want to do is we want to see if this array is actually empty. So what we're going to do is say if array dot length is greater than 0, array 1 length, sorry. Array 1 length is greater than 0, we're going to do some work. Oh wow, I'm just messing up on the keyboard today. Anyway, so we're going to take a second array, and I'm going to name this array 2, just for simplicity's sake. And what I'm going to do is I'm going to run this find sum function, right? But I'm going to run it on array 1. Remember, we're in our main function, so we're just testing this out. And then I'm going to take an int num1 and set that equals to array 2 0 and int num, just copy this actually, whoops. All right, gonna have a int num2, and basically whatever is returned from this function, the two values are going to be thrown into this array 2, right? So let's say num2, and that equals to 1. All right, so after that, we're going to run another if. Further down, create some space. We're going to say if num1 plus num2 is not equals to n. And I just put these in a set of parentheses here so it can just do this math first before it uses this logical operator to check the value or to see if this is equals to n or not. So what we're going to do is we're going to do system .out.print ln. What is this little error? Println, println. Then we're gonna say something like, not found in given array. All right. Then we're gonna have an else block, and in that else block, what we're gonna say is system.out.print line and we're gonna say number 1 is equals to, and add the num1. And since this other line for num2 is going to be almost exactly identical, just copy that, put that down there, change that to 2, change that to 2, and then we're going to also print out the sum. So we're going to say sum equals, and then we're going to say n, because the target value is n, so that's the sum. And it says if it's just found, prints out the num1, the num2, and the sum, right? And that's all Gucci. So we have to have another else as well. And in that else, what I want to do is just print out input array empty, because that's the only other condition that we didn't account for. All right, so we have a couple numbers that add up to 13, so let's just run this. And there you go. We get 2 and 11 because that appears first in the array. Well, it should be 7 and 6. Let's see this. That's 22. Let's run that again. Yeah, we get 7 and 6. Don't know why it skipped over 7 and 6 first, but the function works. Let's just try with a different set of values. Let's try 20 as the target number, and then we run this. Yeah, we get 3 and 17 because 3 appears first, 17. We also have 11 and 9 that adds up to 20. Let's just see if let's run this again and see if we can get something else. Let's see 12, and let's see if we have anything that adds up to 12. We have 7, and then we have 5 here, so that's 12. We have 1 and 11, so that should appear first. Yeah, that appears first. But if we simply added this, change that to 10, the 7 and 5 would appear. Oh, 3 and 9. There we go. That's another set. Not sure why the 7 and 5 are being skipped over. But we can see that if we add it, we take this 9 out. Let's take this 9 out. And let's run that again. We should get 7 and 5. Yeah, 5 and 7. So yeah, that's it for this tutorial. Like, comment, and subscribe for more content. And I will be giving you lots more coding interview questions, and I'll be taking it section by section, or topic by topic rather. So like arrays, linked lists, graphs, dynamic programming, that sort of thing. And thanks for sticking around. I hope this was able to help, and I hope you're able to gain value from this tutorial. All right, take care, YouTube.